All right, today we are diving into a really critical safety update, one that impacts a huge part of the global long-haul fleet. We're talking about EASA Airworthiness Directive 2007-0201 Revision 1. It becomes effective October 23, 2025. And believe me, if you operate aircraft with Rolls-Royce Trent 700 series engines, this is one you absolutely need to know inside and out. So let's get right into it.
So here's what we're going to cover in this explainer. We'll start with the why, the directive's root cause. Then we'll pinpoint exactly which engines are affected. After that, we'll walk through the technical must-dos for compliance, look at the operational and financial side of things, and wrap up with a clear plan for making sure you're fully compliant.
So, first things first, let's get into the why behind this AD. Understanding the root cause isn't just background info, it's absolutely essential for grasping why these actions are so important and why they've been put in place.
The whole story really starts back in October 2003. There was a very serious incident, an uncontained IP turbine blade release, that was kicked off by an internal engine fire. That event is what led EASA to issue the original directive back in 2007. Now, fast forward to today, and this new revision, effective in 2025, is all about refining those original requirements based on well over a decade of real-world in-service data. So what's the actual culprit here? Well, it's a phenomenon called oil coking. Think about it. Inside a jet engine, you've got incredibly high temperatures. At those temps, lubricating oil can actually break down and form these hard, baked-on carbon deposits. And for the Trent 700, the big worry is these deposits blocking the HP/IP turbine-bearing oil vent tube. That blockage was a key step in the failure sequence that happened back in 2003.
Okay, so now that we get the root cause, let's nail down exactly which assets are affected. This next part covers the applicability and the full scope of this directive. This AD applies to the Rolls-Royce RB211 Trent 700 series, specifically these 768, 772, 772B, and 772C models. And here's the really crucial part. It affects all serial numbers, no exceptions. And since these engines are what power the Airbus A330 fleet, which is everywhere, you can see how this directive has some pretty massive implications for airlines and lessors all over the world. All right, let's get into the real meat of the directive, the technical compliance mandates. This is the what you need to do part for all the camo and maintenance teams out there on the ground. The compliance process is pretty methodical. Step 1, check if an engine has hit its initial threshold. That's 10,000 hours or 2,500 cycles. If it has, you move to Step 2, perform the inspection and any cleaning of the vent tubes, following the Rolls-Royce service bulletin to the letter. Now, Step 3 is a key addition in this revision. It's a mandatory follow-up inspection of the vent flow restrictor. Why? Well, this part is a potential choke point, and this check is designed to catch any carbon bits that might have gotten knocked loose during the cleaning. And finally, based on what you find, you establish the next inspection interval. This table here really lays out the decision tree. If you find no visible carbon, great. The engine goes back into service and you set a reinspection interval of 6,400 hours or 1,600 cycles. If you do see some carbon, the tube has to be cleaned and a tool has to pass all the way through to prove it's clear. The interval stays the same. But here's the big one, the one that everyone needs to pay attention to. If that tool gets blocked, the engine must be removed from service within just 10 cycles. The directive is crystal clear on this point. There's zero room for interpretation. Let's just put these two outcomes side by side to make it super clear. On one hand, you have a clean finding. The engine stays in service, you just schedule the next look. Easy enough. On the other hand, any level of contamination means you're doing a mandatory cleaning procedure. And the most severe outcome, finding a blockage with that tool check, that immediately triggers a non-negotiable engine removal. This right here is the key operational risk that this entire AD is designed to manage. Okay, we've gone deep on the technical side. Now let's shift gears and talk about the business implications. This next part is a summary of the operational and financial impact, something for the management and commercial teams to really chew on. And the implications are pretty significant. First, you've got the planned aircraft downtime for the inspections themselves. But what's way more costly is the risk of unscheduled maintenance if a blockage is found. That can easily spiral into an AOG situation and a very expensive engine change. And finally, for anyone dealing with leases, non-compliance or a history of engine removals can introduce some serious risks and financial headaches into those agreements. This isn't just a maintenance task, it's a full-blown fleet asset management issue. And that brings us to our final section, ensuring full compliance.
This is the call to action, the final word for every single operator affected by this directive. You know, the language from EASA is about as direct and legally binding as it gets. The regulation states it plainly. No person may operate an aircraft to which an AD applies except in accordance with the requirements of that AD. It's pretty simple. Compliance isn't optional. It's a fundamental part of continuing airworthiness.
So, the final directive is really simple. Coordinate and comply. This is going to take a unified effort. Your planning, engineering, and maintenance teams all have to be on the same page to make sure this AD gets done on time every single time. And remember, always go back to the official EASA AD and the latest Rolls-Royce service bulletins for the complete authoritative instructions.
And that brings us to our final thought. Look, this AD is about reacting to a known risk, and that's crucial. But it also begs a bigger, more strategic question for every operator out there. Is your predictive maintenance program robust enough to catch the early warning signs of oil coking before an engine removal becomes mandatory? That's the real challenge, and frankly, the opportunity that lies ahead.